Hi everyone, welcome to this video on lesson 5 of the Particles and Energy Scheme on useful and wasted energy. So this builds on the energy transfer diagrams that we were drawing in the previous lesson, but it introduces these two new categories of useful and wasted. And again, the structure of this lesson is very much I do, we do, you do, because I think the best way for students to get this concept of or this idea that we can categorize applying energy transfers as useful and wasted. The best way is just to see lots and lots of examples. One thing to note before we start, obviously this relates to the concept of efficiency. I don't tend to cover that at Key Stage 3, or certainly not in Year 7. The reason being, efficiency is really just a mathematical construct, and my main focus in Year 7 is to get students thinking qualitatively and identifying different energy stores or whether it's useful or wasted. So they're really familiar with that, so that by the time they get to Year 9, when we start putting some maths into the energy unit, or Year 10, whenever it may be, they're really comfortable and they can, oh yeah, I know what useful and wasted energy is. So this lesson just focuses on identifying useful and wasted energy. It doesn't focus on efficiency. Obviously, if you finish what's in here and you have a bit of time, efficiency would be a great thing to talk about. So the first example I use, which I think is a really important example when we come to talk about efficiency, is the light bulb. So I'm going to draw my light bulb like this. As always, this is not a work of art. So here's my light bulb. And what I tend to do is sketch in pencil the fact that the light bulb gives out light. So this is something students are familiar with. And I really want to emphasize here that it gives out light. That's what we use the light bulb for. And that word use is worth emphasizing because obviously it relates to useful. Now, then through some questioning, what do you feel if you put your hand near a light bulb or something like that? I'm going to elicit this idea that, again, they should all be familiar with, that actually light bulbs don't just give out light, they also give out heat. And I tend to do this in red, just because that's a colour they tend to associate with heating. And I think this approach is quite nice because it shows that there's two different things going on. Now we're going to then sketch the energy transfer equation. So I'm going to sketch this in like this. Now I talked about in the last video how this is a bit of a tricky one because there's not really an energy store at the beginning because it just comes from the national grid. We don't know how it was stored originally. So we tend to just write electrical here like this. And you'll have to just excuse the fact that you're going to leave this blank. What I'm then going to do is show that the light bulb changes the pathway effectively, so that all of that energy that was transferred in electrically is transferred out of the light bulb in two different ways. Now, I always try and put the useful energy transfer at the top, and the wasted energy at the bottom, or if there's more than one wasted energy, kind of going down. But I always try and put the useful one at the top, and that's really useful when they're doing calculations around efficiency or even conservation of energy, because it just gets them thinking about it in a habitual way. It's worth saying here, I've written electrical. You may well, if you've been teaching for a while, and this is how I always used to do it, you may have been more familiar with writing something like this. So electrical, arrow, light, plus thermal or something. I mean, this is kind of fine. This will kind of work. So I wouldn't worry too much about it. If we are going to be pernickety though about the way that the new spec is talking about it, when we're talking about useful and wasted energy, we are talking about transfers. So this is the energy that's transferred in. There is a useful transfer out, which is radiation. And there is a wasted transfer out, which is heating. And really we should put, and I think I forgot to put this in the last video, that through this wasted transfer, the thermal energy store of the surroundings increases. But to be honest, I tend to just say energy is wasted by heating the surroundings. And that word surroundings is really, really important. And I've, to you, who I'm sure are familiar with this, I've already kind of given away the punchline and talked about useful and wasted energy. What I would do with students is draw this out first like this, because we did this in the last lesson. There is nothing new here. It's just recapping, going through that same thought process that we went through last time. And all I would do here is then introduce these two new categories and say, well, we're going to put the radiation here because what we use a light bulb for is to light up the room. So this is what we would call the useful energy transfer. Whereas this one down here, we don't turn the light bulb on to heat up the room, so this is what we would call the wasted energy transfer. And again, this is super simple, but this is a year 7 lesson, and all we want students to be able to do in the rest of the lesson is to be able to look at appliances like a light bulb or whatever, and just identify how is energy transferred in, what's the useful energy transfer out, and what is the wasted energy transfer out. And remember, what we're talking about here is this sort of model where useful and wasted refer to transfers, not stores. So let's look at another example. Now I would probably do this as a we do, so get students to do this on whiteboards. Maybe I would sketch the diagram for them. So the next example is a kettle. So I'm going to draw my kettle like this. Just a little spout there. And I'll show that there's a heating element. I might even show that it's plugged in just to remind them that this is an electrical transfer. So I might show them it's plugged in like this. And I'll put my heating element down at the bottom here. Hopefully they'll have seen that. You could even show them under the visualizer if you've got a kettle to hand. So this is my heating element here. And again, what I want to see here, and they would do this on whiteboards, but I'll just go through it here, is something very, very similar. So again, what we would have is an energy transfer in, and that's going to be an electrical transfer in. You'll see with most of the appliances that we tend to think about in this unit or in this topic, they tend to be electrical appliances. So you tend to have an electrical transfer in, but they're not usually battery powered, so you don't need to put chemical store there because it's coming from the national grid. We don't know how energy was stored in the beginning. So we'll just put electrical in and not worry about it too much. Now this is an interesting one. So if we have the water in here, how I might illustrate this if I was going to give them some clues, it's say, well, okay, I know that the temperature of the water is going to increase and that's going to be useful, but I might just draw a bit of steam coming up like this, and I might even, like I did with the previous one, kind of show that the kettle itself is getting quite hot, like that, just to give them that clue that again, we're wasting energy by heating the surroundings. So then I would draw my two lines. Excuse me for my pen, which doesn't seem to be working anymore. Let's try that. So I'm going to draw this like that. Now, again, what's important here, one mistake students are likely to make is that they might think of sound as the wasted energy. Now, yes, there is some sound that comes from a kettle. That isn't what we use it for, unless maybe we find the sound of a kettle quite soothing. But the amount of energy that is transferred mechanically in terms of bumping air particles that cause sounds to reach our ears, that's absolutely tiny compared to the energy that's transferred by heat in the surroundings. And this is the really important point that you want to get across this lesson, is when you're thinking about wasted energy, by far the biggest form of wasted energy transfers is heating the surroundings. So again, what I'm going to put here is, well, the useful energy here is heating, which increases the thermal energy store of the water, but there's also some heating going on, which increases the thermal energy store of the surroundings. Now, there's lots and lots of other examples like this. In the other examples, I don't even ask them to do these energy transfer diagrams, but if they can do these and they're practicing doing these, which I don't think are too, I don't think they're beyond year 7s, that's going to put them in a really, really, really good place for when they get to Key Stage 4 physics and they have to start thinking about all of this stuff in a more methodical way. We'll see as well in the next lesson on conservation of energy, these sorts of diagrams become really, really useful for thinking about conservation of energy, because the only thing we're going to add in that lesson is just the idea that the amount that you put in here electrically is just equal to the total amount that comes out. And hopefully you can see these lessons build very, very gradually. They keep coming back to the same ideas and they just add one extra layer of complexity each time. So the next lesson will be conservation of energy. Thank you for watching this one.